Hello everyone, my name is Qing with metric number of MA19322. Today, I would like to present about my individual project on measurement and instrumentation, which is BMM3533. Introduction. DaisyLab software offers real-time acquisition, analysis, control, and the ability to create custom graphical user interfaces, in contrast to other graphical programming environments, which can require weeks of training to master. DaisyLab has a very short user learning curve. Many applications can be configured in a few minutes rather than days or weeks. Sophisticated acquisition and control tasks can be solved with DaisyLab quickly without any additional programming. Simply insert the appropriate module blocks into the worksheets and connect them by virtual wires with a few mouse clicks. Objective of the project. Use DaisyLab to demonstrate the sensor system and observe the graph. Record the data produced by the stem mixer through microphone. Design a system in acquire data from microphone and show data in time and frequency domain. And this is the example of stem mixer. Brief review on selected sensor. Microphone. A microphone, colloquially called a mic or mic, is a device or transducer that converts sound into an electrical signal. Microphones are used in many applications such as telephones, hearing aids, public address systems for concert halls and public events. Several types of microphones are used today, which employ different methods to convert their air pressure variations of a sound wave to an electrical signal. Principle of application. When you speak, sound waves created by your voice carry energy towards the microphone. Remember that sound we can hear is energy carried by vibration in the air. Inside the microphone, the diaphragm, much smaller than you will find in a loudspeaker and usually made of very thin plastic, moves back and forth when the sound wave hit it. The coil, attached to the diaphragm, moves back and forth as well. The permanent magnet produces a magnetic field that cuts through the coil. As the coil moves back and forth through the magnetic field, an electric current flows through it. The electric current flows out from the microphone to an amplifier or sound recording device. You have converted your original sound into electricity. By using this current, you can effectively store the sound forevermore. Or you could amplify the current and then feed it into a loudspeaker, turning the electricity back into much louder sound. There is house PA, which is personal address system, electric guitar amplifiers, and rock concert amplifier works. Industrial application. Development of innovative smart system incorporating micro-electromechanical parts, assisted by sort of autonomous characteristics supported by dedicated application-specific integrated electronic modules. Effectiveness of this process is a measure for company competitiveness embracing initial idea specification, design, modeling, and simulation stages, assisted by virtual fabrication, optimization, final verification of the design. And then now we move to complete sensor system. So this is the table or the diagram of the complete sensor system. We start from an input energy form and then to sensor elements, which is modulating energy forms, and then to sensor, to the modulating device, and out to output energy forms. As noted in the preface, the Committee on New Sensor Technology, Materials and Application was asked to identify novel sensor materials could benefit the manufacture and operation of advanced systems. And then theoretical background on acoustic measurement to provide necessary background for understanding of the topics. The best definition and other aspects related to the physics of sound and noises are presented. Noise can be defined as disagreeable or undesired sound or other disturbance. From the acoustic point of view, sound and noise constitute the same phenomenon of atmospheric pressure fluctuation about the mean atmospheric pressure. With modern industry, the multitude of sources has accelerated noise including hearing loss, amplified music also take it toll. While amplified music may be considered as sound and give pleasure to many. And then now we move to experimental setup. So the sampling rate and block size determine the number of samples transferred from the driver to DaisyLab and determine how data is moved from module to module on the worksheet. The driver buffer determines how much data can be stored as it moves from the sound card to DaisyLab. So this is the experimental setup when we are using in the DaisyLab. We can adjust the sampling rates and then driver buffers, and just after you have done all of this, just click OK. And then we move to scaling. We can choose linear scaling or interpolation using table of reference point, thermocouple linearization, BT100 or NI100 linearization, or offset adjust. So after defining the input channel for the data acquisition, you must now convert the raw voltage to engineering units. The data acquisition cards reads the data as volts. Okay, now we move to chart recorder. We can add more input, add more output with just click the tick over here and then just click OK, and then the component will have one input and one output as well. So to deactivate a channel, click on the minus button on the channel bar before you close the properties dialog box. So this is the experimental setup of my experiments. The experience is first tested with professional 600 kp26 mix. The analog input is the driver of the sensor system. Write 00 can interpret data from analog input. There will be two graphs produced, which are YT charge 00 and YT charge 01. The FFD 00 can produce the frequency domain graph, which is this one. And then the experiment is repeated with Boron series 7KSM 7586P, which is a more professional machine or stem mixture. So this is the picture of professional 600 kp26 mix, and this is the another one. This is a time domain graph produced by the first one, the first stem mixture. As you can see, the amplitude of it is a bit higher than the B because it has larger sound. So the graph produced is the amplitude produced by the machine is larger. This is the frequency domain graph of the first machine, and then this is the second machine. The amplitude produced is smaller than the first machine, the time domain graph, and then the frequency domain graph. So in conclusion, the amplitude of time domain graph in professional 600 kp26 mix is bigger than in ProLine series 7KSM 7586P. This means that the second machine has better technology and produce smaller sound when it's functioning than the first machine. So through this project, I learned how to use DaisyLab to interpret the data and observe it. That's all from me. Thank you.